Hey everyone, and let's continue with our topics on complex numbers. In this video, I'll be introducing to you how to solve the imaginary number if it is raised to a particular value, which basically means how to solve the imaginary number if it is raised to the power of 2, to the power of 3, or to the power of 29. After that, we'll be going through some examples of this, and when we're done with the examples, we'll be continuing our series on complex numbers with the introduction of how to solve the addition and subtraction, how to perform the addition and subtraction of complex numbers. In math and engineering, you're just not going to get some straightforward questions as 2 plus 3i and solve this equation, or the under root of negative 25. You're going to get equations which would have within them complex and imaginary numbers, and sometimes those imaginary numbers will be raised to different values, so you would have to solve that. How do we do that? We'll see in this video. Now the first one over here is I to the power of 0. We know this, that anything raised to the power of 0 is 1. So if it is 5 raised to the power of 1, that would be 5. 5 raised to the power of 2, that would be 25. 5 raised to the power of 0 would be 1. Just like that, 1000 raised to the power of 0 would be 1. So this is a universal law that anything, this is a mathematical universal law that anything that is raised to the power of 0 is 1. So just like that, I raised to the power of 0 is 1. This also gives us the fact that the value of I would be 1. Now why would we say that? Because value of I is raised to the power of 0 over here. We discussed what the value of I is in the previous videos. We discussed what the value of under root of negative 1 is, which is I. But over here, we see that if that is raised to the power of 0, then we will get 1. Now, moving on. I raised to the power of 1. Anything that is raised to the power of 1 is the same thing again. 5 raised to the power is 1, raised to the power of 1 is 5, 7 raised to the power of 1 is 7, 22 raised to the power of 1 is 22. So this is just basic knowledge. So there's nothing to learn over, there's nothing new to learn over here. So this is just pretty straightforward. Remember that I raised to the power of 0 is 1, I raised to the power of 1 is I. Moving on. Now what would happen if I is raised to the power of 2, I square? Now we know from the previous videos that I is equals to under root of negative 1. I is under root of negative 1. If someone asks you what is I, you would say that I is the under root of negative 1. What would that mean? That would basically mean is that whenever you have a square root, a radical in which you have a negative number inside it, you separate the number and the negative integer with it and the negative 1 with it, and you make it into two expressions. Then you solve for I square and the solution for the next integer that you're solving for. So I square would then become negative 1, which you would know is the imaginary part of the under root. And then moving on, we have I cube. So I cube is nothing except for I square multiplied by I1, because we know that if x square is multiplied by x, and we have to find an expression in the power of x, we would get x cube, because whenever there is nothing written in the power area, the way you write the power of a number, you basically that basically means that it is 1. So over here we'll perform it in the similar fashion. So I cube would basically be I1 multiplied by I square, which will become I raised to the power of 1 plus 2. That will become I cube. So what is negative 1 multiplied by I? That would give you negative I. So this is pretty straightforward. All you have to do is break it down. Break this down into these two, and then you're going to get this. The next thing that you need to know is I raised to the power of 4. Okay, by the way, after I raised to the power of 4, everything is just redundant. Everything is just repeating itself. You don't have to worry about anything after that. You just have to worry about the initial 4, that is I 1 2 3 4, and of course I 0, that is like pretty straightforward. So I 4 is equals to 1. How do we know I 4 is equals to 1? Because we break it down. How do we break it down? I 4 we know is I square multiplied by I square, which will become I raised to the power of 2 plus 2. That would give us 1. Why would that give us 1? Because I square multiplied by I square would mean minus 1, negative 1 multiplied by negative 1. And then we would have I raised to the power of 4 is equals to 1. So these four you have to try to make sense of them. They're pretty straightforward, because if you know these two, you can work out all the rest. But even if you don't know these two, just remember these four and you'll be able to solve all the rest. So I5, how do we get I5 now? I5 can be basically be broken down into I raised to the power 4 multiplied by I raised to the power 1. What is I raised to the power 4? That is 1. If that is multiplied by I raised to the power 1, that is I. What do we get? I. Because 1 multiplied by I is equal to I. Any expression that you get, any expression I raised to the power of 3.2 million, no matter what expression you get, what you have to do is make it a factor of 4. When you make it a factor of 4, you know that anything that is divisible by 4 that is raised to the power I would be 1. After you have that, then you can solve for the rest of these three. I raised to the power of 6. We break it down. I raised to the power 4 multiplied by I square. What is I raised to the power 4? That is 1. What is I square? That is negative 1. And what do we get? 1 multiplied by negative 1 is negative 1. I raised to the power 7. How do we break down I raised to the power 7? I raised to the power 7 can be written as I raised to the power 4 multiplied by I raised to the power of 3. What is I raised to the power 4? Once again, it is 1. What is I raised to the power of 3? That is negative I. So we get negative I as the answer. Let's take another advanced example. So it's not really complex. It's just like the value of raised to the power is 12 over here. So if you look over here, what did I tell you? I told you that you have to make it a factor of 4. So 12 multiplied by 4 is equals to 3. Now 12 raised to the power 4 is equals to 3. What do? Is that we go back, we look over here. I raised to the power of 3 is negative I. It's negative I. So, but you see, the thing is that you don't have to look at I raised to the power of 3. Why? Because I raised to the power of 12 is perfectly divisible by 4. When it is perfectly divisible by 4, we don't have to check the remainder. When you check the remainder, that is when you know which one to pick of all these 4, 1, 2, 3, 4. Over here, I raised to the power of 12, well, you don't have any remainder. The remainder is 0. So what do we get? We have to find the value according to the remainder. What is the remainder? I raised to the power of 0, which would become that 1. Why? Because anything raised to the power of 0 is 1. So what do we have to do is that divide the power by 4. Whatever remainder you get, then you compare it to these 5 over here, 0, 1, 2, 3, 4. That will be your answer. It's as simple as that. Now let's move on to this one. I raised to the power of 17. If 17 is divided by 4, we get a remainder of what? If 17 is divided by 4, we get a remainder of 1. Why? Because 4 divided by 4 is 4 multiplied by 4 is 16, so we get a remainder of 1. So when we get a remainder of 1, what did I tell you? Check for the remainder in all these 5 in all these 5 values. 1 was our remainder. So what is I raised to the power 1? That is I. So this is what we get over here. This is the answer to your question. Moving on, I raised to the power 26. Now what do you get? What is the remainder for this? 26 divided by 4, the remainder will be 2. That is the first step in solving these questions, that you divide the power by 4. Once you are done with that, you go back to the original i's. You check over here, I square is negative 1. So you write it like this, and this will be your answer. Another example, I raised to the power of 11. What will be the remainder over here? If 11 is divided by 4, we know 4 multiplied by 2 is equals to 8. We are left with the remainder of 3. So what do? We go back to the original ones. We go back to the original ones and we see that I cube, that is the remainder is 3. So we have to select this one over here. I cube is negative 1. So this will be your answer. I cube is equal to negative I. So remember that whenever you get a value of I, you check these are steps to solve it. First thing you have to see is whether the value of the power is greater than 4 or less than 4. If the value of the power is less than 4, then you select from the first 5 over here, 0, 1, 2, 3, 4. That is the first step. This is the first check that you have to make. After you're done with the first check, what do you do? If the the power of I is greater than 4, what do you do then? Then you divide it by 4 and you check for the remainder. So whatever the remainder is, that will be the power of I, and that will be your answer. So it's pretty straightforward. First is a check, second is a division. Check if it's greater than 4, you divide. If it's not greater than 4, you just pick out from these 5 over here, 0, 1, 2, 3, 4. And if it is greater than 4, all you have to do is find the remainder. When you find the remainder, you go and check from the original values, that is 0, 1, 2, 3, 4. After you're done with that, that would be your answer. So that is pretty straightforward. Just remember these steps and you'll be good with any value of I. So now moving on. What makes two complex numbers equal? If two complex numbers are represented in this form, a plus bi is equal to c plus di, the only way we can call them equal in this terminology of the complex numbers and imaginary numbers, if the real parts are equal and if the imaginary parts are equal. That is the only way. You cannot find the value of it. You cannot say that it is equal because of some other reasons, because you can't take the square root. What if it's 2 plus 3i and it is being checked against 1 plus 4i? Now if you take the square root of the integers over here, the real numbers over here, you're gonna get 5 because the total number is 5. You don't do that because that is not what's being asked over here, because the square root is not going to give the answer. You're just adding them, because 2 squared plus 3 squared is different from 1 squared plus 4 squared. So what you have to do over here is that you have to check the real values and you have to check the complex values. If the real value is a and the other real value is c, if the real values are equal and the imaginary values are equal, then only will you call it an equal complex number. If two values are like this, then we call it an equal complex number, otherwise we don't. So if you ever have a question, if you want to check the answer of your solution that is equal to some other complex numbers, the only way to do that is if the real numbers are equal and if the imaginary numbers are equal. That is the only way you can check if these complex numbers are equal. So now let's go on and move on to the addition and subtraction of complex numbers. So the addition and subtraction of complex numbers is pretty easy. All you have to do is you have to remember that the real number does not add with an imaginary number, because if that is the case, then we would never have this expression over here, because these two will add. So you have this expression over here, 8 minus 3i plus 2 plus 5i. What do you do with this? What do you do with this? You combine the like terms. What that means is the real number with the real number and the imaginary number with the imaginary number. So 8 plus 2 are the real numbers that you're going to add over here, and negative 3i plus 5i are the imaginary numbers that you're going to add over here. So what basically happens over here is that it's pretty straightforward. You just check the expressions, you check for the real numbers, you check for the complex numbers, imaginary numbers, and once you're done with that, you just add them in the particular way that you do with real numbers. There's no rocket science over here, there's nothing complex over here. 8 minus 3i plus 2 plus 5i, that's what you get. Now one thing that I want you to remember over here is that what if it were 8 plus 2 plus 5i? What if there was no negative 3i? What are you going to do with that? You can't add them again and again. What you're going to do with that is you're going to leave this out of here. So that's just going to be 5i, because the only imaginary number in this expression is going to be 5i. 8 plus 2 would be 8 plus 2, that's going to give you 10, and 5i would be 5i, because we don't have any other imaginary number on the other side. Now let's take another example over here. 8 plus 7i plus 12 plus 11i. So what do? This first thing you have to do is that you look at the question, right? So first thing you do is that you look at the question, you see the expressions, you add what you have to add, that is the real number with the real numbers and the complex numbers, imaginary numbers with imaginary numbers. So 8 minus 12, you're going to group these two over here. 7i plus 11i, you're going to group these two over here, and you're going to get negative 4 plus 18i, just like you do in the arithmetic of real numbers. There's no complexity over here, everything is straightforward, and this is what you do. So another thing that you have to remember over here is that once again try to imagine, what if this were only 7i? Only 7i plus negative 12 plus 11i. What would you do then? What you'll do then is that you're going to add 7i to 11i, and you're just going to write negative 12 over here, no 8 over here, because there was no 8 over here. So the answer would then be negative 12 plus 18i, because the real numbers are only added with the real numbers and the imaginary numbers are only added with the imaginary numbers. Let's take another example. 9 minus 6i minus 12 plus 2i. So this is basically the same thing. Whether you add or subtract is basically the same thing. Over here there's the addition operator between these two expressions. Over here it is the addition operator between these two expressions. Over here it is the negative operator between these two expressions. You don't have to worry about anything. First thing you do is you realize, okay, you look at the question, you say, okay, this is an addition or this is a subtraction. After you're done with that, you combine the like terms, that is, you combine the real terms over here and the imaginary terms over here. 9 minus 12 would be over here, and negative 6i minus negative 2i. Why? Because the second expression is being multiplied by a negative sign over here. Remember this. You're just going to add them once again with the second expression in their negative forms. That is 9 minus 12i, because this is minus 12, and minus 2i over here. You're just going to add these two expressions, and that way you're going to get the answer to this question. So just remember, it's pretty straightforward. Just see whether this is addition. Just look at this. Just look at the expressions and you'll see what to do and what not to do. Just remember that the like terms are going to be added to the like terms. That is real numbers to real numbers and imaginary numbers to imaginary numbers. If there are no real numbers, you can write 0, but you can't add them to imaginary numbers. Like if this were negative 6i, you can write 0 minus 12 over here, because this first equation has 0 real number, but you cannot write something else instead of this. So this is pretty much it for this lecture. In the next lecture, we will be continuing with this series, and we will be starting with the multiplication and the division of complex numbers. Thank you very much.